today we've got a really great topic, and we've got an incredible expert on the topic. And I'd like to introduce everybody to Todd Swinderman. If you've not seen our Foundations series of books, it's really something that you should have in your arsenal. You can download those free at our website. But Todd is the former CEO and president of Martin Engineering. He is also the primary author of those Foundations books, and he's the chief editor of the most recent SEMA publication. So, Todd, thank you very much for joining us today. I chatted a little bit with Todd the other day on what he's going to talk about, and I think this is incredible content.
All right. Well, thanks, Jared. But what I want to accomplish today is just kind of give you a background on conveyor standards development, how they're developed and how they're classified. And then I want to talk specifically about B20.1, which is the ASME conveyor safety standard. In the United States, there's three organizations that are really involved with putting safety standards together. ASME is the Association of Mechanical Engineers. I'm a member of that, have been for quite a few years. And they have various committees. You're probably more familiar with like the pressure vessel code. Well, that comes out of ASME. I'm on the B20.1 committee. The interesting thing about that is it's all volunteer, and it has quite a combination of different members. And anybody's welcome to join that has an interest. And just to give you an idea here of the different types of companies that are involved in the B20.1, I've got Market Sprocket here. Maybe some of you have heard of that. You've probably heard of Bridgestone, the conveyor belt people. Amazon, believe it or not, Amazon has tens of thousands of conveyors. They're not bulk, but they are conveyors. SEW Eurodrive, Honeywell. And then there's a number of individual consultants like myself that are on it, and also some associations like SEMA is a member of ASME B20.1 committee. ASME develops the standards, but ANSI is an organization that kind of oversees the development, has kind of a format that you follow. And they actually publish them and sell them. And then depending upon the standard, they require a review of peers every 3 to 5 years. So they'll go out for comments from end users, from engineering firms, from fabricators and installers, and keep the standards up to date in that way. And then SEMA is the Conveyor Equipment Manufacturers Association. I've been involved with them for about 30 years. And that's an association of manufacturers, engineers, and integrators. And integrator is just an installer. It's a term used more in unit handling. And SEMA covers North and South America. And basically they're focused on standardization like idler dimensions, belt widths, and manufacturing tolerances, things of that nature. But they do have a substantial section of SEMA that's involved with safety. And we'll talk a little bit about that as we go on. Safety standards are divided up into three different categories. Type A is just kind of a basic safety standard, and a good example that would be the OSHA law, not the regulations, but the law. And basically the most important thing in OSHA law for us is the general duty clause. So there's two parts to that. It basically says the employer has a responsibility to provide a safe workplace free of any hazards, known hazards that can cause injury or disease. But it also has a part B, and it says the employees must follow the rules. Well, that's kind of the type A. It's just a general saying, you know, you got to make it safe and your employees have to behave. Type B is more generic, covers maybe one type of safeguarding, like guarding, used everywhere. So maybe a standard just on general guarding, how strong to make it, how to attach it, that sort of thing. And in type B, there's actually for particular safety aspects. Maybe there's something that's kind of tricky to guard that comes up repetitively, and they'll have a standard for that. And then just general safeguards like e-stops, things of that nature that cover a wide range of machinery. And then type C, this is where you get down to a specific machine like conveyors. And we're talking about primarily about fixed in place conveyors, conveyor belts that handle bulk materials. So most of what's in B20.1 would be considered type C standards. And you'll see a mixture of type B and type C in different standards. There's the introduction to B20.1 is a type B standard, just kind of gives the lockout, tag out, some of those things. You know, you don't work on the conveyor while it's running, those kinds of general standards. In the type C area, though, there's two types of standards called performance standards. That basically says you have to guard the nip points. Doesn't tell you how to do it, but it says they must be guarded or they shall be guarded. Where a specification standard would say you must guard the nip points so that the gap between the guard and the belt is 5 millimeters or less, something of that nature. So most standards are a combination of both. So you'll see that throughout B20.1. And then in the standards, there's some words you need to pay attention to. The term shall or must means you have to do it. It's mandatory. And you won't see must used hardly at all anymore. Everybody's moving towards shall. It's considered a more legal definition for mandatory compliance. But you'll also see a lot of should. For example, a competent engineer should design the conveyor. It doesn't say it has to, it says it should. And so the should indicates, well, maybe there's some different situations or circumstances that would modify what you're going to do. For example, you might have the maintenance guys throw together a little conveyor because you're going to run a test for the next 2 weeks of putting an additive in, and you need a place for the front end loader to dump it in. You're probably not going to go out to an engineering firm and pay a lot of money to have this design. You're going to tell your maintenance guys, you know, throw me together a little 20, 30-foot conveyor similar to the one we got over there, and just make sure it's guarded and everything. So that's kind of the difference there. And more often, you're going to see explanatory comments in the standards. Now, explanatory just means it helps clarify what the meaning is, what the intent is, or it could simply be a graphic. B20.1 has some of that type of explanatory stuff in it. You'll see that there's some graphics there. It just says, okay, if you don't know what a vertical reciprocating conveyor door is, this is what it is. So those are some of the types of standards that we work with. Now, what motivated me to get into this safety thing was years ago, I started looking at safety, and particularly with MSHA, you will see that right in here, there were a lot of accidents. Well, that was during World War II. Then after World War II, it kind of leveled off and really hung around the same number of fatal accidents per so many miners or workers. Then right here, that's where OSHA and MSHA came in, and they dropped another order of magnitude. But what concerned me is out here. According to the regression line, we should have been accident fatality free somewhere in the early 2000s, and we're not. And my personal preference is moving more towards specification type standards, and you'll see that like in the ISO standards or the Australian standards, you'll see a lot more specification. The reason I'm moving in that direction is those countries with specification standards, right down here, have fewer fatal accidents than countries like the United States that has primarily performance standards. So for me, it's kind of a personal challenge to improve safety and reduce not just fatalities, but all accidents. Conveyor safety standards started back in the 20s. And interestingly enough, it wasn't really a safety standard, it was terms and definitions. And it was brought up by the leading manufacturers because they felt that they were being unfairly competed against because they didn't have terms for the different parts of the conveyor. So somebody could sell them a conveyor that wasn't really a conveyor, but call it a conveyor, for example. So they wanted to control competition. Person driving that had health issues, passed away. Then World War I came along, and nothing really happened until the first standard was published in 1947. It took some time because these standards are developed by consensus. In other words, the people on the committee, we try to all agree. Doesn't have to be 100%, but we always strive for 100% agreement on the language that's in there. So the first B20.1 was in 1957. And then today we have B20.1-2024. SEMA, the Conveyor Equipment Manufacturers Association, has a lot of good documents, and Jared mentioned the SEMA belt book. It was first introduced in 1966. It's about 800 pages today on how to design conveyors. But their very first standard was terms and definitions, following on from that original group that was concerned about fair competition. But SEMA also has a very active safety committee. For example, this one is on e-stops. This one is on risk assessment. And they have a safety label program. You can buy safety labels from them that comply with the ANSI requirements for safety labels, but they're more specific to bulk material handling conveyors. Well, in 1970, the OSHA Act came out, and buried down in there in 1926.555, subsection A, subsection 8, it says all conveyors shall meet the requirements of ANSI B20.1-1957. So B20.1 is incorporated in OSHA by reference, which makes it law. It means you have to follow B20.1 for conveyor safety. Interestingly enough, Canada also includes ASME B20.1, but they say 1993. So this is a good question here. If OSHA says 1957, but other standards give a different date, which date do you follow? You always follow the latest edition of that, and you'll see a lot of the language in OSHA and MSHA regulations starting to change to that. Rather than give a date, it would say most current version of ASME B20.1. The ASME B20.1 standard is revised every 3 years. There are other standards that apply or have applied in the past to conveyors. Many of you may be familiar with B15. That was the old machinery standard, how close the tool rest has to be to the grinding wheel, how close the guard needs to be to the platen for press brakes or shears, those kinds of standards. And a lot of those were applied to conveyors, either correctly or incorrectly. And a few years ago, the B11 committee undertook a complete revision of that B15 standard and harmonized it with ISO, because so many companies produce for countries that require ISO. The difference between B1119 and B20 is B1119 is focused on point of operation. In other words, somebody's standing there all day long putting parts into a punch press or doing some type of activity where they're repetitively exposed to a hazard. So the guarding requirements for that are much more stringent than what we apply in B20.1. On conveyors, what we're trying to do is prevent inadvertent contact. So if you're walking along the conveyor and you trip on something, you don't accidentally fall into a nip point or onto the conveyor. So there's no real work. The conveyor's doing work and moving the material, but the operators and inspectors are not really doing any real work. And then, of course, maintenance is an important issue, because in some cases you've got to do maintenance while the conveyor's running. For example, tracking the belt is one of the most obvious examples given. So there's exceptions for that. So B20.1 is organized in sections. There's a bunch of introductory sections, and then it gets into general safety standards. So these would be your type B standards, and you can see there's a whole list of things that they look at: maintenance, backstops, brakes, chutes and switches, guards and guarding. This is just general. In other words, nip points shall be guarded. Transfer and loading and discharge points, you got to design them so they don't spill material all over the place. Risk assessment, that applies to all types of conveyors. And dust hazards, this is one we recently added, because you should really, when you're working on a project, consider, is there a hazardous dust problem? We're all familiar with the latest push on silica dust. And from what I hear from the regulators, they're pushing not to control not just hazardous dust like respirable dust, but all dust, because it's been shown that just the nuisance dust, which really doesn't immediately make you sick or give you cancer in the long term, it causes coughing, watering eyes, makes it an unpleasant place to work, and creates safety hazards. Then in section 6, you get into specific safety standards, and 6.1 is belt conveyors fixed in place. Now, it's not very robust in here. You've got your general standards, and then you've got your specific standards. In B20.1, the specific standards for conveyors are one column. There's not a whole lot of information in there. It just addresses specific hazards for conveyors fixed in place. So for example, one of the things it does is it gives you a list of typical nip points to guard. I'm on a project team, and we're looking at trying to significantly update B20.1 to be in parallel with ISO and Australian standards, Canadian standards, all the major mining, South Africa standards, to bring it up to date and make it more modern. Some of the stuff that's under discussion, excuse me, right here. Risk assessment responsibilities. That's a big topic of discussion these days. Who's responsible for doing a risk assessment? I want to add a safeguarding appendix. In other words, how specifically do you guard the tail pulley? What size mesh should you use? How far should the mesh be from the hazard? Or for another example would be the weight of the guard should be 50 pounds or less, that sort of thing. Counterweights and tensioners. We've got gravity counterweights covered. You got to put a fencing or a guard around the bottom of it, so if the belt breaks or the suspension breaks, nobody gets hurt. But tensioners aren't covered, and tensioners can actually be quite complex mechanism. For example, if it's got a winch take-up and wire ropes and those types of things. Those need to be covered. Car wash conveyors, that's an interesting case here of how a lot of these standards start. Car wash conveyors weren't even on our radar, but one of our members does expert witnessing on lawsuits. So a lot of these standards come out of accidents that have happened and members who were involved in them. Turns out car washes are actually pretty dangerous because one particular type where the conveyor is underneath and a little dog comes up and catches your wheel and pulls you through. Well, that's been catching some of these kids that are working these car washers and drags them through the conveyor, and some fatalities have resulted. So that's kind of how different standards get implemented, because a member company or a consultant has been involved in something and said, hey, we didn't even think about that. So we need to add that to B20.1. B21 is kind of a catch-all, all kinds of different conveyors, not just bulk material handling conveyors. For example, slat conveyors. A lot of times those are used in bulk and unit. Pick modules, that's unit handling. Another interesting one is the Association of Car Park Manufacturers, believe it or not, there is one of those, came to us and said, what are the standards for car park conveyors? These are basically elevators that take cars and move them and store them, and you can park a lot more cars in a smaller space. So we're looking at that. A few years ago, there was a rash of accidents on portable car unloaders, people stepping over the conveyor between the rail car or the truck and the conveyor mechanism, stepping on the belt while it's running, getting thrown hopefully off of the conveyor, but sometimes they get thrown into the conveyor. So that's another example of what we do, what we're looking at. We're also looking at the lockout tagout procedure. This is one that you're seeing more and more block out and test out added. Test out seems to be more popular than block out. Lockouts when you put your lock on there and you put your name and your contact information, you de-energize the conveyor, you remove all energy sources. Tag out is when you just put a red tag on it and say, don't operate this equipment until further notice, or until Joe gets over here with his sledgehammer and fixes it. So there's a difference there. It's two separate procedures, often confused to be one. Block out is one of the things that I push a lot, and I'll show you why on the next slide. Over on the left-hand side, I just wanted to point out what's new in 2024, and you can see those are just kind of minor changes. The last two, like an e-stop. If there's an e-stop on the wall or a column somewhere, I don't know about you, but when I'm working, I'm thinking, what happens if I push that button? Well, there was no requirement that those types of e-stops be labeled for the equipment that they cover. So just kind of a minor improvement, but an important one. And then we already talked about dust hazards. There's a requirement that you might have to do a dust mitigation exercise if you have hazardous dust. So let's look at block out. This is a fatal accident that just happened in July. Conveyor was out of operation, evidently stopped full of coal. And a couple of guys are up on the belt shoveling the coal off, and all of a sudden the conveyor rolled backwards, buried the people cleaning up at the tail end, and killed one of them. Now, I called MSHA last week to see if there were any more details available, and it's still an active investigation. I wanted to know, was there a backstop on this conveyor, or was it a brake that they depended upon? But this is a perfect example where if they had blocked it out as a standard maintenance routine, that conveyor belt would have not rolled back and that person would still be alive. It's probably hard to see, but only about 5 years experience, mining experience for this gentleman that passed away. That's why I think block out is important. Test out is also important. I don't know about you, but I've been involved in situations where you're working on a conveyor and let's say it's interlocked with 2 other conveyors so that you don't have one conveyor running onto a stop conveyor. Well, operators and electricians have a habit of jumping out sensors or switches that give a lot of false alarms. And it's often quite possible that you think the conveyor feeding the conveyor you're working on is inoperable. And the best way to figure that out is once you do your lockout and your block out, push the button. Does it run? And does the conveyor on either side of it run? A lot of serious accidents have happened that way. Oh, risk assessment. This is a hot topic being discussed in our committee and several others. Risk assessment is just a fancy word for job safety analysis, or just sitting down and thinking what could go wrong and how do we avoid it. I think people generally concur that the manufacturer is responsible for sitting down and thinking about, this is my product, this is the intended use, what are the main hazards. For example, on a conveyor belt, obviously the pinch point between all the rollers and the belt. So the manufacturer should do a risk assessment and guard those before he sells it. The engineer and designer, this is probably the first line of defense. They're responsible basically for going over the system. Do we have all the interlocks right? Do we have the interfaces? Are the controls proper? Not only that, but structural. Is the structural analysis correct? Have the right strength of belt. There's a lot that the engineer and designer does. Perhaps not thinking that he's doing a risk assessment, but as he's making the evaluation of what type of belt to use and this sort of thing, he's actually doing a risk assessment. Then the person who installs it also has a responsibility to do a risk assessment. And quite often, the customer will say, as part of your contract, when you're done, I want you to do a walkthrough with us, show us how everything works, where the problems could be, what the hazards are, that sort of thing. Make sure your manual's put together and covers everything. But what's often not talked about is what is the end user's responsibility. And you often hear the question and says, well, OSHA says I'm supposed to follow B20.1-1957. This conveyor was built in 1958. I don't have to bring it up to standard if I move it or change the raw material I put on it or modify it in some way. Well, actually, you are responsible for looking at any new hazards that may be created and any hazards that may have been resolved. And that should be a formal process where you look at it and document it. The point of contention is bringing the conveyor up to current standards. So the direction that we're headed is that if you do modify a conveyor, relocate it or repurpose it, you've got to bring it up to the current standard. So that creates a whole bunch of conversation about, well, what do you mean by modify? It's not normal maintenance that we're talking about. We're talking about, let's say, a lot of times people speed up the conveyor to increase capacity. That's a modification that needs a risk assessment. Relocated and repurposed are a little easier to understand, but I'm pretty sure that this is going to become a requirement in B20.1 with the next edition. This is an example from Canadian safety standard, a specification standard. How high do you make the guard so you can't reach over it, under it, or through it, or around it? What size mesh do you use? And you'll see, particularly the European standards, they got this little ruler that they use. And so the little narrow part, you can only stick that in maybe 50 millimeters. So that's the size of mesh you need if the hazard is only 50 millimeters from the guard. To me, this is totally impractical in bulk material handling because we're not point of operation. We're trying to prevent inadvertent contact falling against the conveyor. And I particularly like the Australian approach where they just say, no, we're going, all your guarding should be 2-inch mesh. They give you a couple different wire sizes you can use, and all your guarding should be 8 inches or 200 millimeters from the hazard. So you'll see conveyors in Australia so nicely and neatly guarded from one end to the other with 50 by 50 mesh. That makes a lot more sense to me. The problem with this ruler and using these smaller sizes in bulk material handling, a lot of what the operators do is walk along the conveyor and look for problems. So if the mesh is so small you can't see through it and it's covered in dust, that tempts the inspector to take the guard off and see what's going on. So that's one of my pet peeves that I hope to eventually get put into B20.1 is safeguarding from a practical standpoint fixed in place conveyors. Another one that bugs the heck out of me is what's called guarding by location. And there's like 3 or 4 different distances. Canada has different distances than OSHA, and OSHA has different distances than MSHA. And I really think in bulk material handling, it's really not that appropriate because as I show here, yeah, if there's no buildup under that roller, it's guarded by location. But as soon as you get a buildup and somebody can stand on top of that, and we all know that in a lot of places that buildup just becomes permanent under the conveyor, you can get into the hazard. And I'm not sure how to do this, but I've done a lot of inspections where I'm crawling around conveyors and I see things like chain drives on bucket elevators that aren't guarded. And well, it's 40 feet in the air, don't need to guard it. Well, somebody may be up there inspecting. So we're going to take a hard look at that and probably restrict the use of that in the future. These standards are all developed voluntarily. And we'd like to think we have the best minds out there working on this. But that only happens if you get involved and be proactive. You can join SEMA if you qualify as a manufacturer and conveyor engineer or a conveyor installer. You can join ASME just because you feel like it. There are really no requirements other than that you have a background in the subject matter. And they have a process for adding people to the committee. What's important here is that you and your organization, if they're involved at the ground level, can short circuit any crazy ideas that some consultant from the government has about how you should guard your conveyor or how you should operate it. If you're not in that room, chances are nobody's going to think of the things you think of because you're there every day working on it. And it's really a great way to meet different people in the industry. You have awareness of what's going on and you have networking. For example, just 2 days ago, I got a call from a salesman that said, hey, this wasn't safety related, but it's an example of network. He said, hey, I'm out here at a mine and I see I'm supposed to maintain this belt cleaner, but it looks like it's a XYZ brand and I can't find anything online about it. Do you know what's going on? Well, I just happen to know, one of the executives it happened to be a belting company that was involved. So I sent him an email and said, hey, you guys used to sell this conveyor belt cleaner. Are you still selling it? We can't find anything online. And within 8 hours, I got an answer back. No, we got out of that business and those products are no longer available. Well, that's just one example of how there are benefits other than just donating your time and your intellect to improve safety to getting involved in these organizations.
Thanks for joining us, everybody. Have a great Thanksgiving weekend.
All right. Thanks, everybody.
Thanks,
Bye.
Todd. Thanks, everybody. Have a great day.